Hi, so in this question we're going to approximate the solution to this cubic equation. So we're told that the root lies between 2 and 3. So a root of an equation is quite straightforward. It's essentially, if you draw the graph of the equation, so this one here, I don't know exactly what it looks like, but it's a cubic, so it can have up to 3 solutions. So a cubic generally will look something like this. The point being, it will hit the graph, hit the axis, specifically the x-axis, at most 3 times. So these are where this graph here, so this equals 0. So essentially we're told that it hits the x-axis at a value between 2 and 3. So using trial and improvement, we need to find what this value of x is pretty much. So to do this, we simply just use a grid of values, and we just proceed by trial and improvement. So this is going to be our x part, and then for this we're going to have the actual equation, so x cubed minus 8x plus 3. So we're only required to go to 1 decimal place here, so it's not too bad. So we're told first of all that it lies between 2 and 3. So let's evaluate this at 2, and let's evaluate this at 3 as well. So 2 is going to be the smallest value we look at, and 3 is going to be the biggest. So I'm going to place them down here, and I'm going to try my best to keep them in order, because it is kind of good housekeeping to do so. So when I put x is 2 into this equation, so if I use my calculator, so 2 cubed minus 8 times 2 plus 3, so that I will get that to be minus 5. And when I put 3 into the same equation, so putting 3 into this, so 3 cubed minus 8 times 3 plus 3, using my calculator, I will get x is 6. So what we're looking for here, and this kind of proves that my point, so at each of these points, the way we look for them is that the y value at them is 0. So going from this point to this point, the y value has gone from positive to negative, and in this one it's gone from negative to positive. The point being, around these points, if we pass through them, the sign of the value changes. So as we can see here, between 2 and 3, it's gone from negative 5 to 6. So therefore there must be, yeah, as the question says, there is a root between these two values. So we need to find that root correct to 1 decimal place. So what we do is, let's hone in on it a bit. Let's go for the logical approach, which is 2.5. So 2.5 is fairly reasonable. It's in the middle of 2 and 3. So I now evaluate this function at 2.5, and I put that value into my calculator. So 2.5 cubed minus 8 times 2.5 plus 3. And I get this to be minus 1.375. So we've gone negative, slightly less negative, so we're getting close to 0 where it'll change sign. So let's proceed in the same way. So let's go to 2.6. So we're looking for it to change sign. So again, 2.6, and we put it into this. So 2.6 cubed minus 8 times 2.6 plus 3. And using the calculator, we get this to be minus 0.224. So almost there, we're getting really close now, so let's go to 2.7. So 2.7 cubed minus 8 times 2.7 plus 3. I get this to be 1.083. So between these two, we have a change in sign. So what this means is the root, the value we're looking for, is between 2.6 and 2.7. So because we're rounding to 1 decimal place, it is going to be one of these two, but now we need to work out which one is closer to. So let's do that. Let's look at in between these two and see if it changes sign. So if we go in between, that is 2.65. So if this remains negative between 2.6 and 2.65, it's negative and then still negative. So it hasn't crossed the axis at this point. So it means that the root is closer to 2.7. But if this changes to positive, that means it's got between 2.6 and 2.65, it's gone from negative to positive, so the root must be between 2.6 and 2.65, and therefore closer to 2.6. So let's go through, let's actually put this value in and see which one it is. So putting this value in, it is 0.409625. So this is a positive value, so it's gone from 2.6 to 2.65, it's gone from negative to positive. So somewhere in the between 2.6 and 2.65, it's changed sign. So the root is between 2.6 and 2.65. So because we want it to 1 decimal place, it's just 2.6 because we know it's closer to 2.6. So the root here is 2.6 to 1 decimal place.